Brain cancer has become the leading cause of death in children from cancer. Unfortunately, because as we've made tremendous progress in pediatric oncology, the progress for childhood leukemia and other tumors has far outpaced the progress we've made for children with brain tumors.
Several decades ago, childhood leukemia was a near universally fatal disease, and now over 90% of children who have childhood leukemia survive because of enormous strides forward based on great research and clinical trials.
It's quite easy to get leukemic cells to study. And in contrast, brain tumors are likely a more difficult to treat group of tumors, and access to tissue has always been challenging. That lack of tissue really slowed down our ability to understand the molecular basis of childhood cancers and how they evolve over time.
Childhood cancers evolve over the course of the disease. They change in response to the therapies that we give. They're very tricky and mutate and truly undergo an evolutionary process to get around whatever therapy it is that we're trying to administer. As a result, it's really important to study the tumors throughout this progression so that we have a sense of how we can fight them in the beginning, as well as how to fight them when they recur.
Treating a tumor in a child's brain is like trying to reach for a moving target. So we know that we need to study both the tumor at diagnosis and at the times of relapse, and unfortunately even at the time of death, so that we can understand the changes that will give us clues so that we can better treat these tumors.
One of our largest gaps in knowledge is, why do our treatments fail? Why do they work only in some children and fail in others? In order to better understand that, tissue obtained after a child dies, post-mortem tissue, may contain the key information of the changes that have occurred over the course of treatment and over the course of time. That tissue can be invaluable to unlocking the mysteries that still exist in a number of our childhood brain tumors.
When we receive the tumor tissue, we try hard to establish a viable, durable cell culture, something that grows in a dish that we can renew, that we can save, that we can share with other researchers. And with a resource like that, we can study possible new therapies, we can screen for new drugs, we can put those cells into the appropriate location in the brains of mice and treat the mice as sort of a preclinical trial. One of the things that we have learned from whole brain donations is the extent that a particular cancer may be actually spreading through the brain in ways that aren't easily detectable with standard diagnostic and neuroimaging modalities. When we're able to study the entire brain, we can learn a lot about patterns of invasion, possible mechanisms that might contribute to recurrence of the tumor, the way that the tumor interacts with the normal cells in the brain.
I can think of no greater gift from a family during the worst possible moments in their life. These tissues that are given under the most extremely difficult situations really will make the ultimate difference in how we understand the biology of childhood brain tumors.
Advances in the treatment of children with cancer have come about because of the great collaboration that has occurred amongst physicians, scientists, patients, and families across the country. That collaboration now continues today, not only between physicians, institutions, patients, and families, but between scientists working in the laboratories around the country and around the world, all sharing information, sharing advances, and all committed to finding better treatments for children with brain tumors. What I think is common to most children and families is not only do they want to have better treatment for themselves, but they don't want any other family to experience what they've gone through. Donating tissue post-mortem to help other children with cancer is, in fact, a step in the healing process of an unimaginable loss.